Alright, this is class example program unit F1, page 4. It's a very, very simple example. Let's take a look. Air flows through a 0.08 millimeter diameter passageway in a person's lungs at a rate of 10 to the minus 9 cubic meter per second. This is volume flow rate, obviously. Is the flow laminar or turbulent? Support your answer with appropriate calculations. Okay, so very first step usually in pipe flow analysis is to find out if the flow is laminar or turbulent. So how do we know if the flow is laminar or turbulent? Well, we have to calculate Reynolds number. So let's just check the Reynolds number. If the Reynolds number is less than 2100, very famous Reynolds experiment. Based on that, this guarantees that the laminar flow is in the pipe. Okay? So obviously, if the Reynolds number is lower than this value, you can say the flow is laminar. Okay? If the Reynolds number is more than 4000, this is called turbulent flow. Okay? Anything in between will be called transitional. So in this case, is the flow laminar or turbulent? So first of all, let's find out the average velocity based on the given flow rate Q divided by the cross-section area. Okay? Flow rate Q is given by 10 to the minus 9 cubic meter per second. It's pretty low value, isn't it? So I guess the passageway is so small diameter, so each one of those passageway can only take this much flow rate, but you have lots of passageway in your run. Anyways, okay? Pi over 4 times diameter of each passageway is 0.08 millimeter times 10 to minus 3 meter. Okay? This is going to give you velocity average 0.199 meter per second. Let's use this velocity to find out Reynolds number. Reynolds number is rho PD over mu. Keep that in mind. You can alternatively determine Reynolds number by using velocity times diameter divided by mu. Remember, this is called absolute or dynamic viscosity. This mu is mu divided by rho. This is called kinematic viscosity. Okay. Now usually people really don't tell you if the viscosity is absolute dynamic or kinematic. They only use the term viscosity. So you have to make a judgment if the viscosity they're talking about, people talk about, is either kinematic or absolute dynamic. How can you tell that? By looking at the units. If the viscosity is kinematic viscosity, typical unit you're going to get is meter square per second or feet square per second. Very simplified units. That is the feature of kinematic viscosity. Okay? So by looking at the units, you can tell the viscosity you're talking about is kinematic or absolute dynamic. Okay? So you can look up the table, property table, and find out both properties, either absolute dynamic viscosity of air or kinematic viscosity of air. So let's use the kinematic viscosity. Kinematic viscosity of air is 1.46 times 10 to minus 5 meters squared per second. Make sure you look up your own property table, which is handout, to check to see if you can get this right. Kinematic viscosity of air. Velocity is 0.199 meter per second. Diameter 0.08 times 10 to minus 3 meters. Make sure your meter and second all consistent units. Okay? So if you pick up your calculator, put those numbers in, this is going to get you 1.09. Oh, it's a really low value. This is a low Reynolds number flow. This is much, much lower than 2100. So the flow a person's lung is laminar. Okay. So one important thing about if the flow is laminar flow of the pipe. Has analytical solution. Okay, so we can analyze laminar flow in a pipe using analytical solutions. And also, if the flow is laminar, this is something called friction factor of a pipe. Friction factor of the pipe depends only on the Reynolds number. So you can calculate pipe flow, especially laminar flow, fairly easily. So we are going to probably take a look at the laminar flow solution first in the pipe, and then we are going to move on to the turbine flow. Okay? Let's stop here.